Hello, ladies and gentlemen. Today what we're going to talk about is the second method that we want to use to solve a system of equations. And what we're going to use is what we call the substitution. Now, before we even start, I'd pause it. You're going to need a piece of paper. All right, you're going to write down your own notes today. So make sure you have something to write with. Because all this stuff is what you're going to, everything we write on here, you're going to want to write down also. Because these are the notes you're going to use in class on Friday. So you have an opportunity to look back on what you learned today. So, solving a system of equations using substitution. The same idea is true. You are still looking to see where the two lines intersect. Your two equations, x plus y is equal to 38, then x equals 2y minus 25. These two lines are going to intersect at a point. As long as they intersect at a point, you'll be able to find the solution, an x-coordinate and a y-coordinate. Now, the reason why we have substitution is because not everything can be graphed. If you look at these two equations, the way they're not written very well. They're not written in our lovely little slope-intercept form. Y equals mx plus b. Right? They're not written in that form, so it makes it tougher to be able to graph them. Another reason why we might want to use substitution is that you don't have a graph. Right? So we want to be able to have another method to be able to solve a system of equations when graphing is not available. Right? So what we're going to do with substitution. The first step in substitution is to look. Is there a variable, either x or y in this case, that has been solved for, that is all by itself? And we have that here. When you look at these two equations, this x has been solved for. In other words, it's on the side of an equation all by itself. So x has a value. Now this is the toughest part about substitution, is understanding what the value of x in this case is. The value of x is this 2y minus 25. Yes, I understand it's not an actual number because we don't know what y is, and that's okay. But y represents a number. We just don't know what that number is yet. X is equal to this amount. Alright? So as we look at this equation, or either of these equations, as you look at them, we can't solve these. The reason why we can't solve them is because we have two different types of variables in here. You don't know how to solve an equation with two different types of variables. And that's okay, because we haven't gone through that yet. We do know how to solve an equation with one variable in it. So what we're going to do, and what substitution is about, is we are going to create a new equation using these two equations that are working together. Remember, these two equations are working together as a system. They're working together to form a point where these two lines intersect. So what we're going to do is we're going to use these two to create an equation that has only one type of variable in it. Alright, so from this point, x has been solved for in this equation. Its value is 2y minus 25. Well, knowing that these two, when they cross at the same point, they have the same value. If x is equal to 2y minus 25 here, then what we can do is we can substitute into the other equation 4x. And what we can substitute in is this 2y minus 25. So, this equation right here, the first one, I'm going to rewrite it. And how I'm going to rewrite it is instead of writing an x, I'm going to write what this value of x is. So I'm going to write a 2y minus 25. That's the value of x. And then plus y equals 38. If that did not make any sense, rewind it, listen to what I said again, and then move on. Alright? Now, from this situation, what you'll notice is now we have only one type of variable. We have y's. You guys can solve an equation with one variable in it. You can combine any like terms. 2y plus y is 3y. And then we have a negative 25 is equal to 38. After that, it's just like a two-step equation. Add the opposite of negative 25, which is a positive 25. So both sides. That's 0, so you get 3y is equal to, as we go through this, 38 plus 25 is 363. After that, divide both sides by 3. Y is equal to 21. Now, each time you solve this, remember, you are trying to find a point where these two lines intersect. What you've found so far is the y coordinate. And that's great. We found the y coordinate. And if you notice, y coordinate 21, well, that's kind of hard to graph. So that's one of the reasons why we have substitution. Sometimes you can't even graph the problems you have. The thing that we're missing, though, is the x coordinate. Well, after you find the y coordinate, the x coordinate is actually really easy to find. Let's go back to your two original equations. These two up here. Now, when we look at these two, you have a y in each of these. Well, once you know what the y value is, you can substitute it back into either equation. It doesn't matter which one. Once you know what the value of a variable is, a letter, you don't need to write the letter anymore. You can write its value. If I were to do this problem, I would choose the second equation. And I would plug that 21 in for y. When I would do this, I would write x is equal to 2 times y, which is now 21, and then minus 25. And then I would solve that. 2 times 21 is 42. 42 minus 25 is 17. So you now know what the x-coordinate is. The x-coordinate is now 17. So if you were to graph these two lines, they would cross at the point 1721. Hopefully one thing you'll notice from this is that this point isn't going to show up on any graph that I give you. All right? This point, if we had a graph, it would be way up here somewhere. All right? So this is one of the reasons why we have substitution. It allows us to figure out the answers to systems when graphing isn't available. All right? Now the question always asked is, well, which equation do I choose to find the second part? As I said, it doesn't matter. You could choose the first one. I could take that 21 and I could have substituted it in there. X plus 21 instead of a y equals 38. At this point, I just add negative 21 to both sides. And as you can tell, negative 21 plus 21 is 0. 38 minus 21 is also 17. That's the nice thing about a system of equations. Both equations are working together to get the same answer. All right. Let's move on to the next one. Remember, at any point in time, if you want to go back, watch this, go ahead. The next one, negative 2x plus y is equal to 6, and y is equal to 3x plus 9. As you look at this, the first thing you're looking for is an equation that is solved for, is by itself. Well, what we have is we have a variable y that is by itself, okay? So knowing that, its value, in this case, is this 3x plus 9. What we're going to do with that value is we're going to substitute it into the other equation for y. So, in this second one, instead of writing y, we're going to start off with the 2x plus, or negative 2x, plus the value of y. Instead of a y, we're going to write 3x plus 9. This is the value of y. And this is all equal to 6. And again, the reason why we're doing this is because you can't solve an equation with two different variables in it. You can only solve an equation with one type of variable in it. So we're manipulating it and creating a new equation that has only one type of variable in it. So at this point now, you can solve this. Negative 2x plus 3x gives you 1x. Plus 9 is equal to 6. Add negative 9 to both sides. That's 0, so you get x is equal to negative 3. So what you have now is you have an x-coordinate of negative 3. And as what we did in the last problem, you still need to find the y-coordinate. Well, the way that we do that, again, pick an equation. It doesn't matter which one. If I were to choose, I would choose the second one. And instead of writing an x, I'm now going to write a negative 3. So y is equal to 3 times x, which is now negative 3, plus 9. 3 times negative 3 is negative 9. Negative 9 plus 9 is 0. So, the y-coordinate is at 0. If you were to draw these two lines, they would intersect at the point negative 3, 0. That is the solution to that system of equations. Alright, over here I have this little proof thing. Well, there's a way for you to actually check to see if you're right. To know whether this point is a solution to these two equations, when you look at this, you should get true statements if you plugged in negative 3 and 0 in for x and y in each one. And that's what I did over here. When you look at this, in the first equation, negative 2x plus y is equal to 6. I plugged a negative 3 in for x and a 0 in for y. Negative 2 times negative 3 is 6. 6 plus 0 is 6. Well, is 6 equal to 6? Yes, that's a true statement. As long as you get a true statement, it's true. But it also has to be true in the second equation. 3 times negative 3 is negative 9. Negative 9 plus 9 is 0. Well, is 0 equal to 0? Yes, that is a true statement. If you were to get 0 equals to, we'll say 18, that's an untrue statement. So that means that whatever you would have gotten over here would have been wrong. It wouldn't have crossed at that point. Basically what this is saying is that this point makes both of these equations true. All right? It gives you a true statement. All right. We're going to move on. All right, for this one, not a big deal. This is a pretty simple one. What this is you practicing the first step to solving a system of equations. The first step is the substitution part. And for some people, that's the toughest part. Identify the variables by itself. The variables by itself here is y. Its value is this negative 2x plus minus 1. What we want to do, just for today, is take that value and substitute it in for y in the other equation. Well, y is right there. This means 3y means 3 times y. So when we write this, we have 4x plus 3 times the value of y. Well, now our value of y has changed. It's not just the letter y. It's now negative 2x minus 1. That's equal to a negative 3. This right here represents y. All right? That is the first step to solving a system of equations using substitution. All right? Being able to substitute that value into the other equation. Again, we're creating an equation that has one type of variable so that you can solve it. We're going to try it on another one. Now, when we look at this one, you'll notice we have different letters. You're going to notice with system of equations, they will use a lot of different letters. The nice thing about the lettering is think about your coordinate, x, y. Well, it's in alphabetical order. So if we have A and B, that's how you'd write it as a coordinate. Not a big deal. All right, so let's take a look. When you look at this, look, which equation has a variable that's all by itself? Well, if you notice, A is all by itself. Its value is negative 3b plus 3. What we want to do is take that value of A and substitute it into the other equation, 4a. I will do this every single time. I will write this box, I will circle where I want to put it, and draw a line to it so I know where I'm going to substitute it in for. So when I write this, I'm going to write 2 times whatever the value of A is. Well, now I'm saying the value of A is negative 3b plus 3. And then I'm going to write the rest of it, which is plus 9b equals 7. All right? And again, this represents A. 2a plus 9b equals 7. That's basically what I'm writing here. That's the first step to solving a system of equations using substitution. Let's try one more. This is one that kind of messes people up every once in a while, so I want you to see this. Sometimes you have to use substitution even if it is in slope-intercept form, because you can't graph it on a graph. You got a y-intercept of 19, and I don't give you any graphs that go that high. So as we look at this, we're going to try to put this one in slope-intercept form. The nice thing about this one is it doesn't matter which equation you choose. They're both solvable, so you just choose one. I'm going to choose the second one and say y is equal to this amount x plus 7. And what I'm going to do is I'm going to substitute it in for y in the other equation. So I'm going to have, instead of a y, I'm going to have an x plus 7. Then I'm going to have a negative 2x plus 19. And I'm going to solve this one. Okay? So at this point, I can solve this. So when I look at this, I have variables on both sides. I'm going to move my variables all onto the left side. So I'm going to add the opposite of the negative 2x, which is a positive 2x, to both sides. 2x and x is 3x plus 7. Negative 2x and 2x is gone. So I have a 19 left over. So now, as I notice, I'm down to a two-step equation. I'm going to add the opposite of that 7 to both sides. That's 0, so I'm going to get 3x is equal to 12. And I'm going to divide both sides by 3 to get x is equal to 4. So I've got my x-coordinate to where these two lines are going to intersect. Now I'm going to substitute that 4 into each equation. I want you to think about it. When you choose an equation to solve it for the second part, choose the one you think is the easiest. For me, the easiest is that one. Less work to do. So I'm going to put in y, and the value of x is now a 4. And then plus 7. Well, 4 plus 7 is, makes that one really easy, 11. You're done. So if you were to look to see where these two lines intersect, they intersect at the point 411. Alright, again, anything on there, you need to rewatch it. Substitution can be very, very hard. Watch it again. If you have any other questions, see me in the morning. You might be able to get those answered really quickly. Alright? Guys, have a great day. Bye.